Now for question 1, alright, for question 1, if you observe, this is going to be under simple harmonic motion. Simple harmonic motion, SHM, for both alternative A and alternative B. But the only differences might be that you might not use all of this. For alternative A, it might be simpler. For alternative B, it might be more difficult. But you should know that in either case, what you are going to do here is simple harmonic motion based on the apparatus given to us. You need stopwatch, you need two restore stand. One, you might need only one. You need thread, you need two identical spiral spring, you might need only one, or you might not even need them at all. A meter rule, then these masses, okay, you might need all of them, or you might not even need any of this. You might only need the pendulum bulb, then two screws of uniform thread. You might not need this. Then stopwatch, very important, optical pin, and plasticine. So these are the apparatus we are told to get for our practicals. Now take note of these practical tips. Please screenshot it and then make sure you go through it on your own leisure time, and make sure you abide by these instructions. They will help you to pass adequately. So let's delve into the practicals directly. So for question 1, I expect that since we are using uh, two spiral spring or whatever, one of the questions might come in this format. Okay, we might need a clamp with a meter rule. Okay, either we need two clamps or we might only need one. Then with two spiral spring or even the two. So take note of this particular diagram. Alright, so you have your clamp with a meter rule, you have your spiral spring, your pointer, your mass, and then you have this mass dangling on this. So if it comes this way, a spiral spring is suspended vertically from a rigid support and a meter rule is clamped vertically in front of the spiral spring as shown in the figure above. With no mass attached to the spring, the position of the pointer L0, without this mass, L0 is expected, that's the height from the maximum height here to the part where the spring ends on the meter rule is read and recorded as A. Then mass M equals 100 grams. You now suspend 100 gram mass on this at the free end of the spring, and the new position of the pointer L of the loaded spiral spring is read and recorded. The suspended mass is set into vertical oscillation and the time T for 20 complete oscillation is measured and recorded. Now if you look at it from the white paper, you will see that our masses for this year are what? We have 150, 200, 250, 300, and 350. So expect these masses to be given to you. So if you're able to achieve that, then what do we do next? The procedure requires you to repeat for M is 200. If you observe, the masses for this is 200, 300, 400, 500, 600. While for this we are 150, 200, 250, 300, and so on. So please take note of this variation, but the practicals are similar. Remember, your L1 is your new height, then or the increased height. Your L0 is your original height. Please take note of this. So measure and record the real value of L0, which you are meant to do at the beginning. Measure and record the real values of L1 and the corresponding values of T1 based on the time you were able to obtain the 20 oscillation. In each case, determine the period T of oscillation and evaluate T squared and E equals L1 minus L0. So your new height minus your original initial height. Exactly. Before you depress this or stretch it, merely you hung the mass. This height, this spring is expected to stretch. Exactly. So what it means is that without the mass, you have your L0. Once you attach the mass, this spring will be stretched. It gives you your L1. Okay, that's what you are going to use here. All right. Then before you begin to oscillate vertically to get your 20 oscillation and your time t1, please take note of this particular aspect. Then plot a graph of E on the vertical axis against T squared on the horizontal axis, starting both axes from the origin. Alright, determine the slope S of the graph. So you are expected to state two precautions you would take if you were to perform the experiment in the laboratory. Of course, you perform the experiment, so you state the two precautions. You can be asked to explain what is meant by the period of oscillation of an oscillatory body. A spiral spring is compressed by 0.02 meters. Calculate the energy stored in the spring if the force constant K is 400 Newton per meter. So for simple harmonic motion, you are expected to set up your experiment this way. Alright, you can see your spring, your mass attached, then you can depress it a little and release to obtain up and down vertical motion. And then your period or your time given might be 20 seconds or even 10 seconds depending on how WAEC we set their question. So what you are expected to do is to be varying the masses. Alright, as you obtain your values, you vary the masses and then you take notes of your time. Okay, your stopwatch must be working perfectly. Is that unclear? Then you did seconds. Okay, using your stopwatch for 20 oscillation. This is your time. Is that one taken? Then your period is time over the number of oscillations, which will give you this table. Then your t squared, you are going to square your period, which will give you this particular table. Observe the values. They are in 3 decimal places. Make sure you do that. Okay? If they are clashing, make sure you use 3 decimal places or 2 decimal places. Then your E is L1 minus L0. Your L1 43 minus 39 gives you 4.0. Then let's look at this part now. If you look at this next one, you will see that 47 minus 39 will give us 8. 51 minus 39 will give us 12. 55 minus 39 will give us 16. 59.5 minus 20.5 minus 39 will give us 20.5. And then 63 minus 39 will give us 24. So the graph line is the line of best fit that I'm going to draw. So we have been told to plot a graph of E, which is the extension. Now this one, this is giving you a clue of elasticity, which you have F, which normally you know that F equals what? Ke. Are you here? So please take note of this particular experiment. It might come in this format. So if you're able to understand this concept, this becomes your extension. So you are plotting a graph of where is it? Extension against period. Sorry, you are plotting a graph of extension on the vertical axis against t squared on the horizontal axis. Extension against this. So if you're able to achieve this, this is how your graph will look like. Alright, your graph will be a graph of E in centimeter against t squared in s squared. Your scale can be 4 cm for 5 units on the vertical axis. You are carrying out the practical, so your precaution must be well written. Remember that the period of oscillation of an oscillatory body is the time taken for one complete cycle of oscillation or the time taken for one complete to and fro movement of the body. The energy stored in spring equals half kx squared. And if you do this, you have this as your answer. You can see it's a very simple practical. So make sure you are prepared on this. Now, if your practical doesn't come in this format, this is the one you will expect. Very simple. You would expect this one. Okay, where you just have your rigid support. Okay. You might likely also have something similar to this. All right, just take note of this. You might have something like this. It might not come this way, but just know that these are different alternatives that can come out in WAEC. All right, it has to do with either up and down motion or to and fro motion as simple pendulum, where you have your rotor stand, exactly, and then you hung your pendulum, okay, on the cock, and then you measure the height. You'll be told to measure this height, exactly, and then the height from the floor will be give you y, and then the height from the rotor stand to the floor also give you capital letter H. So the practical can come in this format also, and then you put this into oscillation. So you'll be having something like this. You take 20 oscillations also, and your table is going to look so similar to this one. Is that clear? It's going to look so similar to this one. But here, your E, which is extension, will be converted to this Y. Okay, because you are going to subtract your what? Your H from your Y. If you subtract your H, okay, from this particular part, then you will obtain your Y and you record it. Is that clear? So you can be asked to plot a graph of T against Y also for this particular practical. They are similar to each other when it comes to this, but they are all under simple harmonic motion. So I believe you are aware and prepared for these particular practicals. Check the next practical for question 3. You are expected to answer only 2 questions, but any of these can come out in the exam. So go through them all to get yourself adequately prepared. As I promised you in my last video, I told you that the instruction for physics practicals have been released, and these are the apparatus we are meant to get for question 2. So I'm going to give you the expected questions that will come under this question 2 and what you must do. I will show you how the table look like. I will show you how to plot your graph, and I will show you how to answer some of the questions that are attached to this question 2 when it comes to the measurement of heat. So this one practically is under measurement of heat. Alright, specific heat capacity. So if you are ready, let's go. So under question 2, this is the expected question. In fact, I'm very sure about it. This is how your question is going to look like. Alright, this is 2016 and we are in 2026. This is past question. Can you observe the setup here? You are provided with a beaker, a thermometer, a stirrer, a measuring cylinder, a pulsing burner, a wire gauge, a 50-gram mass, a pair of tongs, water, tripod stand, and other necessary materials. Now, all you need to do is to observe the setup. If you're able to observe the setup, that's what you are meant to repeat during the practical. Your school might provide you with a candle. They might give you a bouncing burner. They might give you kerosene stove. They might give you gas stove. So please take note of this. Is that clear? Then what you're expected to do, they will give you a tongue where you clamp your mass, because your mass will be given to you. Is that clear? Yes, either your mass or whatever will be given to you. Take note of it, because that will be the source of heat. When it is heated, it is being transferred to the water, and then you have your beaker with water, and then you have your thermometer that will be given to you. So you are expected to measure the final temperature of this. You are expected to measure the initial temperature of this. Then you are expected to measure the equilibrium temperature after some specific time. Because if you observe, you see that stopwatch was included in the white paper. So you are expected to be given a stopwatch for a particular period of time. So these are the instructions. Using the measuring cylinder, measure 150 centimeter cube of water into the beaker. record the volume of the water in the beaker. Alright, then calculate the mass m of the water. We are given mass equals density multiplied by volume, and we know that our density here is 1 gram per centimeter cube. Then measure and record the initial temperature theta at 0 degrees of the water in the beaker. I told you initial. Then hold the 50 gram mass with a pair of tongs in the flame of the Bunsen burner for 2 minutes. Can you see your time? So you need stopwatch for this. Quickly transfer the 50 gram mass to the water in the beaker. Then stir gently and record the highest temperature, theta 1, attained. You are expected to evaluate final temperature equals the highest temperature minus the initial temperature. So empty the content of the beaker and repeat the procedure above for other values. So what you'll be doing is that you'll be changing the volume of water inside this container. Alright, the first one will be 150 centimeter cube of water. Alright, the next one will be 200 for volume, 250 for volume, 300 for volume, and 350. Mind you, this can change. Exactly, they can decide to use 50, 100, 150, and so on. But just know that that's how your practical is going to look like. Then you are expected to tabulate your readings. You are expected to plot a graph of m on the vertical axis and theta on the horizontal axis. Determine the slope s of the graph. Determine the slope s of the graph. Then evaluate k equals 50 over s. State 2 precautions taken to obtain accurate result. Define heat capacity. An electric kettle rated this. We are going to answer this question later. So for experiment under heat, these are some of the apparatus we've been given. You might be given a candle, please take note of this. Alright. Then as a source of heat, you might be given some of these things. Please take note of that. Why stopwatch is very important. Alright, because you'll be timing it. So the major thing is to hit your mass. Alright, whatever mass is given to you, hit it. Then you transfer to your beaker, and then you stir using your stirrer, and then you have a thermometer for measurement. So this is how you keep on repeating the procedure. Exactly, your source of heat must be there. You now heat this for maybe 20 seconds or 10 seconds as provided from the question. Then you transfer. Then you stir. And then you observe your thermometer. And then you take your reading. Of course, your initial temperature will be 0. Then the obtained temperature here will become higher than it. But if you're able to carry out this practical as shown, then this is how your table will look like. Very important, please. Look at the table. This is how your table of value will look like. Alright. Now, your volume will be captured because your volume changes. I can see that the change is constant, right? At 50, 50, 50, 50. So in fact, you can guess your temperature with this. Yes, I'm telling you the fact. If you want to save time, once you're able to get your value for 150 and 200, check your question. If the values are constant, then you can be able to guess the rest. Alright. Then after your volume, you are supposed to capture your mass, because your mass will be changing from 150 gram mass to 200 gram mass to 250 gram mass, 300 gram mass, 350 gram mass. So take note of this also. Then you are expected to record your theta, which is at 0 degrees. You have 30, 30, 30. Everything will be constant. Then after that, you are expected to record your theta 1. Okay, for 150, you have 41 degrees. For 200, you have 38. For 250, you have this. So this is how your table is meant to look like. Alright, then after that, you know that you're plotting theta on the graph. So your theta, how do you obtain theta? You say theta 1 minus theta 0. Alright, so if you do this, you are going to have these particular values. So the graph will be shown in the next page. After you are done with this, you are expected to plot a graph of what? V against theta. So let's look at the graph quickly. This is how your graph is going to look like. Alright, make sure your title is captured. A graph of M in grams against theta in degrees Celsius. This is WAEC. You are expected to capture the title. If you fail to capture this title, you have failed. Please take note of that. Then your scale, make sure you capture your scales very well. Alright, then you are expected to use at least the whole of your graph. If you observe this graph, you can see that almost every part of the graph was used. So don't go and draw one tiny thing somewhere on your graph. You are expected to use the whole of the graph. Then if the question come in this format where you plot mass against theta, then this is what you are having. Mass against theta, this is what you are having. So your graph will move this way. Your line of best fits will move this way. So what you will do is to ensure that your values are accurate. And if you observe also, I want to give you a secret. You see that your line of best fits, how many was he able to capture? If you observe, that gives you the value of each of the tiny lines. You do the same thing here. You can see the differences are 2, 4, 6. So I will now say 2 divided by the number of lines here. If they are 10 or 20, I divide them by 10 or by 20. I obtain the value of each of this line. I hope this is helpful. Then after that, you should know that you are expected to answer some questions from the graph. And these are the expected questions. The slope. Your slope is going to be change in y over change in x. So whatever is on your y-axis, okay, against whatever is on the x-axis. So you have the highest minus the lowest, and you are picking it from your graph. You pick it from your graph. You can see that my slope is here. Can you see? You pick from any 2 points from the graph, and I will suggest that you pick the lines of best fits. Okay, you pick the outer one and the inner one, whatever it is. All right, but make sure you know that this is your line of best fit and this becomes your slope. So you take your value for y. This is y2, this is y1, this is x2, and this is x1. So you take your reading and you are good to go. You are seeing that it's looking like a chair. Yes, that's how it is going to look like. So once you are done with that, these questions that are attached, you solve for your slope. Your slope will be negative slope. Is that clear? And your SI unit will be the SI unit of what is on the y-axis against the SI unit of what is on the x-axis. That's why you're having gram for y divided by degrees Celsius in x. That's why you're having grams per degree Celsius. I hope this one is clear. Then you see that the other question, our K, which is 50 over S, you divide 50 by your S, you have 1.8 degrees Celsius per grams. The precautions taken under this practical that you must know. Number one, I ensure that the 50 gram mass was held in the flame for only exactly 2 minutes. This is your precaution. I ensured that there was no delay in the transfer of the 50 gram mass from the flame to the water in the beaker. It was transferred quickly. That is another precaution. And then I ensured that at every new volume of water in the beaker, the 50 gram mass was made to cool to its normal room temperature before it was held in the flame again. Please take note of this. If not, it will affect your value. So what do you do with this? You can easily drop the mass into, since you are changing masses, you don't need to worry about this one. Is that clear? Then question 1b1, heat capacity is the quantity of heat required to raise the temperature of a substance by 1 Kelvin. You can be asked to define heat capacity. Then you can be given a mathematical problem. You should know that if the question comes in that format, then you are expected to solve. Let's look at the question. They said an electric kettle rated 1.2 kilowatt is used to heat. This is the source of heat. This is the heat. This one will not be heat. This is heat lost now. to heat by 800 grams of water initially at temperature of 20 degrees Celsius. Neglecting heat losses, calculate the time taken for the kettle to heat the water to its boiling point. Take the boiling point of water to be 101 degrees Celsius. Specific capacity of water equals 4,200 joules per kilogram per Kelvin. So take note of the way the question will come out in your exams. And if that's the case, you should know that heat gained by electric kettle equals heat gained. You should know that the heat generated by electric kettle, which is heat lost, equals heat gained by water. Heat generated by electric kettle, since it's coming from electricity, will give you power multiplied by time. And we know that power equals current multiplied by volume. We know that power equals current multiplied by voltage. But since we are giving power directly, then we know that we have 1.2 kilowatt, we have power to be 1.2 kilowatt, which is 1,200 watts. Our time and alternative B, they might decide to pick any of this, because you can see pendulum bulb here, you can see beaker containing water, okay, you can see measuring cylinder and the rest. So they can decide to take this in another format, and if they do, this is the second question that can likely come out under question 2. Now this is your question. You observe this. This is one of the question for 2012. Okay, observe the question. You can see that you have your beaker here. Okay, since you have your beaker and this is your what, this can be your meter rule, is that clear? Or whatever device. Now you have your small letter h. Tabulate your readings in the space provided. That is what you are meant to carry out. Then you are meant to plot a graph of h on the vertical axis and small letter h on the horizontal axis. Determine the slope s of the graph. State 2 precautions to ensure accurate result. You can be asked to state Snell's law of refraction, and a glass of thickness T and refractive index N is placed on a dot of ink. So once you're able to do this, you are able to get your slope when it comes to the calculations. Now let's look at how your slope is going to look like. The slope S equals H2 minus H1 over small letter H2 minus H1, which will give you 1.33. You can see that it's giving you the refractive index of water, close to the refractive index of water. So that's what they are expecting you to find or to look for. Then the precautions here are ensure that the water in the cylinder was still, not disturbed when viewed from the top of the cylinder. I avoided error of parallax in aligning the search pin with the image of the optical pins. Then Snell's law of refraction states that the ratio of the sine of the angle of incidence to the sine of angle of refraction is constant for a given pair of media. Okay, then your thickness T of glass is the real depth from that question. Your A is your refractive index of glass, your D is the displacement. Let the apparent depth be this. If you're able to solve this, you solve them simultaneously. If you put equation 1 into equation 2, you have N equals T over T minus D. Cross multiply, you now have N into T minus D equals T. T minus D equals T over N. Then D equals T minus T over N. Is that clear? So take note of this particular part. That is that for the second practicals. I've dropped the other questions. Check them out and prepare adequately. So this brings us to practical number 3 on electricity. If you are lucky, one of these questions will come out for you. Now, for electricity, these were the apparatus we were told to obtain. We have micrometer screw gauge, we have the rheostat, we have a cell of 1.5 volts, we have a voltmeter from 0 to 2 volts, and then we have our ammeter from 0 to 100 milliampere. We have 1 meter long Constantan wire SWG28 or 1 meter long Constantan wire SWG labeled B. One standard resistor labeled RX, and it is 2 ohms. Is that clear? Now you have your connecting wire and your 2 ohm resistor. Can you see it? That's why I said this practical might be the one. If you are very, very serious about this, you don't need to waste your time. Exactly. You can see our 2 ohm resistor, you can see our voltmeter, our ammeter, our key, our cell, then our rheostat. Can you see how the connection is? So you are going to use this to be touching this. So it means you are going to be adjusting the rheostat to obtain the values of either the current or the voltage you are told to obtain. If it is not this one, it might be this. Observe the two. Okay, you see this one. This is your ammeter, also in series, but here we don't have voltmeter. Okay, but we have our constantan wire because we are told to get 2 constantan wire, so likely this can come out. All right, then you have a crocodile clip that you are going to use in adjusting the length of this in order to get your value of current that will be given from the questions. Now this is how your question will look like. If you're able to obtain this for this particular diagram, you are provided with a constantan wire, a 2 ohm resistor. As resistance value decreases, your current will increase. They are inversely proportional to each other. Please take note of this particular part. Then if you're able to achieve that, we know that we are going to evaluate D inverse. This D distance, evaluate D inverse. Repeat the procedure for 4 other values of D equals 80, 70, 60, and 50. So you are meant to do this 5 times. Okay, it might be 90 to this, it might be 70 downward, it might be 50 downward. So take note of this. This can change. You need inverse of distance. So your I naught, when you record it, please put it here. We're having 0.95 depending on whatever you're having. Exactly, because the battery value also determines the current values, which is your voltage value, your PD. So you are going to have this. Observe, we're having 1 decimal places here, 1 decimal places here. That is good. Whatever you want to do, make sure your line of best fits capture the highest number of points that falls on the line. Is that clear? Then you can also obtain your slope. You can see, pick the outer one that falls on the line of best fit to the inner one. So this slope, if you are drawing this for WAEC, please draw this, pick this, and pick this. Is that clear? This gives you your slope. So you pit this against this, and then you pit this against this. You obtain your change in I against change in D inverse. Is that clear? So if you're able to achieve that, then you have the slope S equals I2 minus I1 over D inverse 2 minus D inverse 1. And if you do that properly, your slope will give you to 55.7 ampere centimeters. Why? Because already you are having divided by. So this will cancel out this. That's why you're having ACM as your SI unit. Take note of this. Then your intercept on the vertical axis is 0.975. Let's look at it. This is your intercept, where this your line of best fit intercepts your vertical axis, crosses your vertical axis, and say 0.9 something 95, right? 0. What? 9 0.975. If you observe, 0.975 is close to your original value of current. Can you see it? So this slope intercept C should give you the value of, at least by approximation, the value of your original current as recorded. Is that clear? So your K equals C over S. And what is our C? Our C is 0.975 against what? Against our slope 55.7. Now if you do that, our K is 0.0175 cm. So just know how to obtain this. It will make your work easier to do. Then from the graph, the corresponding value of I equals 2 ampere by approximation will give you what? You now check and you see what is given to you. That's question this. When D equals 55 centimeters, it will give you approximately this value. Then precautions, I ensure that the connections were tight. I ensure that the key is open when not taking readings. I ensure that the crocodile clip has a firm grip on the concertina wire. The potential difference between 2 points in an electric circuit is the work done in moving a unit charge from one point to another. Then the factors on which the resistance of wire depends, we have the length, we have the cross-sectional area, we have the nature of material, and then we have temperature. And it comes from resistivity. Okay, resistivity. If you know the formula for resistivity, it answers this particular question. Is that clear? Because it's RA over L. So if you're able to